let's talk about rhythm. In this video, we're going to go over note values, different note values, and their relationships to each other, including the dot, what the dot does to our notes. So, note values. It's best to start thinking as everything sort of centering around the whole note, because all of the names we use for our notes center around this. Now, what I'm going to create here is something maybe you've seen in your music classes. What we're doing, well, let's back up here. This is a whole note. We're going to represent this is a whole note. We're going to represent this with the number 1. Okay? Now, what we're doing with our different note values, the way they relate to each other, is we're always dividing in half. So when we divide our whole note in half, we get these two half notes. I'm going to designate those with this fraction, half. That's actually where the name comes from, half notes. And we can do this again, divide our half notes, each one of these by 2. We get this new note. These represent 1/4 of the whole. Think of this as 1 over 1, right? This is 1 over 4. 1 over 4. So we call these our quarter notes, because they represent 1/4 of the whole. We can do this yet again, and the way we usually draw eighth notes is beamed like this. Eighth notes, do. Okay. And that represents 1/8 of a whole. Notice as we go up, 2 of these equal 1 of these. 2 of these equal 1 of these, right? But we can also think about the relationships of, say, this to this. 4 of these equal 1 of these. And of course, 8 of our eighth notes equal 1 whole note. So these notes all relate to each other in different very mathematical ways. And we can divide again. Whoa, we're getting kind of squishy here, so we're just going to do 1 of these. Notice that the 16th note is very similar to the 8th note. We just add an extra little line, a little beam is what we call that. So this is 1/16. And if we have 16 of those, we make a whole note. By the way, an 8th note all by itself looks like that. A 16th note all by itself looks like that. Now, you can take this division game into the eternities. And all you do is you add another beam. So these are 32nd notes. Let me write these over here if you did it again. Those are 64th notes. 1, 2, 3, 4, 5. 1/28. Right. You can do this over and over again. So this is how the notes relate to each other. The names of the notes actually go back to a whole note, so if you're ever unsure of what a note value does, you can always relate it back to a whole note or one step up. And the name of the note is actually can be a trigger to help you remember how it fits into the particular measure that you're in. Now, just as important as these note values are I guess we'll call them rest values. So the first one to know is the whole rest. The whole rest is a little bit different. Most of these I'm going to show you, they match right up with this diagram. So you would think a whole rest is the same as a whole note, and that's sort of yes, sort of no. A whole rest actually just fills in a whole measure, and a measure might have 3 beats, it might have 4 beats, it might have 10 beats. But for now, we'll just still represent this with a 1. Now, a half note, let me draw this over here. Half note goes right there. Notice that the whole note and the half note both look very similar. The way I remember which is which is that the whole goes under the line, so it looks like a hole in the ground, like somebody could fall into the hole. And this is like a hat, and hat sounds like half, and that's what this is. This is a half rest. Hat rest, half rest. Right, we got a little guy there. Yay! So here's your half rest. We divide that in 2. We get not the most beautiful quarter rest you've probably ever seen, but that's what those are. Divide your quarter rest, you get an eighth rest. And then you divide your eighth rest, you get a 16th rest. Now notice, from the eighth rest on, we follow kind of the same pattern that we had for beaming. So boom, that goes with that. We have one beam. Boom, that goes with that. We have two beams. And if you want to keep making these 32nd, 64th, 128th. Of course, these, you don't really see these in choral music. You don't really have to worry about these, but it's it's still good to understand the theory behind what's going on. Now, that is our note values. Now, there's something we can do to our note values. We can add dots. We'll call this the dot. Dun, 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 the dot. The dot looks like this. It's a dot. Okay, so let's start by dotting the first note we had. If we dot a whole note, what are we doing when we dot anything? We are adding half of that note to its original value. So if we were going to write this out as a math equation, this equals this plus half of its value, which is that. Oh, I already have the equal sign. Okay, so that's what that equals. Let's go down. Let's take a half note. This equals itself plus half of it, which is quarter note. Notice that when we're adding half, we're just adding the next layer down. So for the first one, I did that and that. And for the half note, I do that and that. And it always works. It's one level down, because one level down is always half of itself. Okay, so we can keep doing this. We get all these different values. Quarter plus an eighth, right? One way to think about what you really end up with this, what you really end up with here, we could write this equal sign again here and show this a different way. It's also, you can think of it as being equal to 3 of its half. So 3 half notes. A dotted half is 3 quarter notes. And how am I getting this? This is because this is 2 quarter notes, this is 1 quarter note, right? Or for the one on top, we have, this is 2 half notes, this is 1 half note. Down here we have 3 eighth notes. Oh, it's a funny looking eighth note. Okay, we can do this forever. We'll do one more just to show you that we can. So this equals an eighth note plus half of an eighth note, which is a 16th note. And that equals 3 16th notes. We'll beam it here. You can try it like that as well if you wanted. Okay. Now, just to show some examples of how dots would normally work, especially as you get into these smaller values. In fact, we'll use that one. This is usually connected to a 16th note. So let me draw just 4 of these so we can get a beat going. So this beat would be dun 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 dun. One way to think about what's happening here is that this is 3 16th notes and this is 1. So you have 1 2 3 1 1 2 3 1 1 2 3 1 1 2 3 1. It's usually faster, so you have dun 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 dun. But that's what's going on there. You can think of that for larger beats too. We don't beam them together like that, but if you have that dun 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 dun. So that's kind of how the dot works, at least in 4/4 time. It might work a little bit differently, but we haven't gotten to time signatures yet, so I'm not going to go into that. This is just an example of how dots get used. Now, just for fun, since we can do it, we're going to talk about double dotting. Now, when you double dot, you add another half of the half, or a quarter. Or if you want to think of it this way, you add the top level, the next level, and then the next level, from wherever you start. So this equals itself plus the half note plus a quarter note. So this plus half of it plus half of it. And that equals, let's see, what can we say about this? This is 7 quarters. So it equals 7 of the quarter of itself. This works for this as well. So we have a half note plus a quarter note plus an eighth note. This equals 7 eighth notes. And I'll show you why it's useful to think of that in a second. Here we're going to add itself plus half of itself plus half of itself, so that equals 7 16th notes. Okay, that's as far as we'll go with that. But you see the pattern. This would keep happening. You just add itself, then a half, then a half. Again, let's show an example of what would happen. Let's start with the whole note. So if we were going to see this in music, and again, this is just an example. This is just one way you might see it. It's not necessarily the only way you'll see it. You'd probably see something like this. Because what we have here is 7 quarters. And then we finish that off with an eighth quarter. Because in 4/4 time, or some kind of quadruple meter, again, which we haven't talked about, but we'll get to it in the next video. That would finish, make kind of a round number of beats. If you're going to use this one, you'd probably end it with an eighth note. Or if you were going to use this one, oops, I didn't want that. This one, end with a 16th note. So if we were going to tap this beat, it'd be da 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 ba. So there's 7 16 notes and then one da 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 da. This double dotting, you don't normally see that much. It's not a bad idea to just think of this as a very quick note. Hold this for a while, and then this happens at the last minute before whatever happens next, probably another quarter or something like that. So that is your basic note values. Your basic rests and what they look like and how they function, how they relate to each other, and then what happens with the dot. And I should mention these dots can be added to rests as well. So that's it for today, and I'll see you next time when we talk about time signatures.